Hello. Okay, this is our 6.1 ratios and proportion notes. So let's go ahead and start by putting your name on each sheet of paper. Remember, I put my name and video so that you guys can actually come see my copy. Okay, so ratios may be a familiar or unfamiliar word to you, and proportions you may have heard of them before. I know that in my mind they kind of get junked together, so I did want to start off by making sure we had a clear idea of which was which. So let's start off by talking about ratios. A ratio is a comparison of two numbers by division, and that is a lot to think about. So I like to just basically say that a ratio is a fraction. So A over B. You might also see it written like this, A with the colon, that's two dots, the colon, B. And the way that we say it is A to B. But we don't always have to stick to that because ratios, you actually use a lot of ratios in your daily life already. And we'll talk a little bit about that in a minute. So you might have, an example of a ratio, you could say 3 over 5. That is a fraction. It is also a ratio. I might say that apples are on sale at the grocery store, $3 for 5 apples. So that's $3 to 5 apples. I might say that there's a deal running on pizza where you can get, if you spend $3, you get 5 toppings or something. I don't know. It's always going to be a comparison of something like that, where it looks like a fraction, where the top represents a number or a value and the bottom represents a value. Another thing that you might be, familiar with is if you think about maybe you're building a garden and you know that you have 7 plants that you need to plant out, and you have 10 feet of space to put them in. So you could say 7 plants to 10 feet. That's the ratio that you want. A lot of times in classrooms, we'll talk about there's, 10 students to 1 teacher, or if we go on a field trip, we have to have a ratio of like 15 students to 1 adult or something like that. Those are all ratios. Last but not least, one that you are absolutely familiar with is this one. I'm actually going to put it up here and see if you can think through it for a minute. 67 over 1. And that's miles per 1 hour. So this is one that you are very familiar with. 67 miles per 1 hour. That's a speed, right? We talk about that all the time. But when we don't necessarily say, oh, I'm driving 67 per 1 or 67 to 1. We don't say that because we know that 67 over 1, this transfers into 67 over 1 mph. That's how we abbreviate miles per hour. 67 per 1 mile per hour, 67 miles per 1 hour. What do we know that 67 over 1 is? We know that that is just 67 miles per hour. So you guys are very familiar with ratios, even if you don't necessarily stop and call them ratios in your brain or think about them that way a lot. Okay, next up though, we're going to talk about proportions. So a ratio is just this. It's just the fraction, pretty much. The proportion is an equation with a ratio on each side. That's it. So it's an equation, so it has to have an equal sign. Okay. An example of an equation could be, I might say, I know that I have 2 is to 17 as 4 is to 34. We can also think about our 67 miles. So if I know that I have 67 per 1 hour, and I want to know how far am I going to drive in 3 hours if I'm going that speed. So I know 1 hour, right? Well, if I want to have the same ratio, I need to know, okay, 3 hours. Let's do 3 hours, but I need to know how many miles. I need to have an X value. I need to solve for that. That is also a proportion. And this is where we get into what we're going to be doing today, which is solving them. So just for clarity, the ratio is just, remember we talked about expressions and equations. The ratio is just the expression, just the fraction on one side. And then the proportion has the equal sign in it. It's the equation. So when you solve proportions, you guys have probably seen this before, but some of you may not have. Has anybody heard of the butterfly method? Butterfly in the sky. I can go twice. No, okay. So basically what you can do is, I know just through math, and I can sit here and do the math and explain it for you if you want, come find me. But I know that if I have a proportion, that this value times this value, so A times D, when they're mushed together, it's multiplication. I know that A times D is going to equal B times C, this value times this value. Okay, and I can remember that they're multiplied because this actually looks like that X that we used to use before we got to algebra to find our, or to show multiplication. So I know that when I have, so for the butterfly method, I know that I have, if I have a proportion and I'm trying to solve for, like, let's say I wanted to know what C was, or up here I wanted to know what X was. I know that this value times this value, so A times D, equals this value times this value, B times C. And we will work through a couple of those here in a second. So go ahead and make sure that you have this first set of notes caught up, this kind of intro part, and then meet me on the first example. Okay, example 1. We have a proportion because it has an equal sign. It has a ratio and a ratio, and we know that these two equal each other. So I know I need to use my butterfly method. So I'm going to go ahead and do my circles. Okay. And I know that this value times this value, A times D, which I have X times 21. I could also write X times 21 is the same as 21 times X, right? X times 21 equals 21 times X, and 21 times X equals 21X, right? I don't have to write that part out. But so we have, so I know that I have this first AD part, right, is going to be 21X equals these two values multiplied together, 7 times 3. So 21X equals 7 times 3. Now I know what to do here. First off, I can simplify 7 times 3 a little bit, can't I? So I know I have 21X equals 7 times 3, if you know it, put it down. If not, that's what you got Desmos for. 7 times 3 is 21. So I have 21x equals 21. Well, I know that I need to get rid of this 21, and I undo multiplication with division. So I need to divide both sides by 21. Some of y'all are already ahead of me and know where we're going. So I know that x equals, well, what's 21 divided by 1, or 21? The only reason we cancel it out over here is because it equals 1. Or you can use Desmos to double check yourself. Okay, so we can cancel it out over here because we know that that's going to get us to an invisible 1, because we don't need that 1 right there, because 1 times x is x. But then we do need it over there. That's not an invisible 1 over there, so we got to have something over there. Okay, there's example 1, and let's take example 2. Okay, Adon and his friends, hold on. Guys, I gotta have the right color, you know it. Okay, Adon and his friends put up 4 trucker tents in 60 minutes on a camping site. How long will they take to put up 5 tents? I need to write a proportion and solve for the variable. So I know that Adon and his friends, and they actually already gave me a hint on how to start here. Go ahead and write your ratios here as tenths to minutes. It really doesn't matter how you write it as long as you write it consistently for the whole thing. So if you write tenths to minutes, you need to also write tenths to minutes. Can't do tenths to minutes, minutes to tenths. Does that make sense? Okay. So Adon and his friends, I've got some important information here. 4 tenths in 60 minutes. And then they want to know how long will it take them to put up 5 tenths. So I know that I have this value here. This is my unknown value. My x is how long is it going to take, right? So that's what I'm trying to figure out. So I know first off on one side of my equation that I have 4 tenths to 60 minutes. Okay. And now they want to know how long. Well, how long, is that going to be my tenths or my minutes? Oh, that's actually going to be my minutes, because how long is minutes? So that's going to be my x. And then they have 5 tenths. Here we go. So you got to be a little careful when you're thinking through these, because we know that how long is going to be my minutes. So don't fall into it and just put x over 5 just because it's the next one that came up in the problem. Got to put your thinking brain on. Okay, so now we know what to do here. We know that we've got our butterfly in the sky method. So we know 4 times x, we can write that as 4x equals 5 times 60. Okay. 4x, let's go ahead and simplify this. 5 times 60, you can put it into Desmos if you want to. Also, I know that 5 times 6 is 30, and then I add this 0 here, so that's 300. Okay. Now I need to get rid of this 4 because I want to get my x by itself. So I need to divide out my 4. My x comes down. And I need to divide both sides by 4. Can't just do it to one side. Okay, you can put this in Desmos if you want. And 300 divided by 4 is 75. Okay, I want to think about this for a minute though. So we said, I want to think, does this make sense? Because we said we put up 4 tenths in 60 minutes. Okay, so if I'm working at that same pace, I want to know how long is it going to take to put up 5 tenths. Well, let's think about it. Is it going to take me less time or more time to put up these 5 tenths? Well, It's more tenths, so it's probably going to take more time. But it's not going to take like 100 more minutes because this putting up 4/10 only took 60 minutes. So it's going to take just a little bit of time. It's not going to take too much time. So if I put 75 in here, does that make sense? Did it take me just a little bit longer? It took me 15 more minutes to put up those 5/10. That makes sense, doesn't it? It makes sense that if 4/10 takes 60 minutes, it's going to take me just a little bit longer to put up that 5th tenth. Okay? Okay, you guys have some practices here. You have some practices on just solving the proportions. And then you do have some practices on the word problems. If you need help, let me know. Have a good day.